This nugget is focused on creating network diagrams. The creation of network diagrams is a process and a set of steps that you will need to understand as you will be tested on them as part of the PMP exam. In addition to that, network diagrams are important to us as project managers because they provide a very critical function in our projects. Network diagrams are going to define the project schedule. By understanding the process, the steps, the interdependencies of all of the tasks on our project, it's going to allow us to define the project schedule. As a result of defining that, it allows us to identify the critical path. What are the tasks on our project that, if extended by a single day, are going to increase our project completion date by the same day? And finally, by understanding and creating the network diagrams, it's going to provide the direct support that we need to act upon as project managers when we're dealing with fast tracking, trying to accelerate the completion of our project, or by crashing, trying to work project activities in parallel. Understanding network diagrams allows us to be better project managers by the definition of the project schedule, the critical path, and the information we need to fast track and crash. In real life, in project delivery, you will probably be unlikely to be creating network diagrams by hand, which is what we're going to be discussing in this nugget. The creation of network diagrams in real life is going to be done by your project scheduling tool, your Microsoft project. It will do everything that we're going to discuss in this nugget for you automatically as a result of using Microsoft Project. But for the PMP exam, you will need to know the processes for creating network diagrams, and again, that's what we're going to cover in this nugget. The creation of network diagrams by hand is a 5-step process. Step number 1, we draw the basic diagram. We identify all of the tasks and all of the interdependencies between the tasks, and we put them on the network diagram. Step number 2, we add the effort required to complete each of the tasks to our network diagram. Based on the effort to complete the tasks, we do our forward pass to the network diagram. We calculate what the earliest start and the earliest finish date can be for each and every task on our project schedule. We then do what's called the backward pass. Working backwards through our project diagram, we calculate what the latest start and the latest finish is going to be for each one of our tasks. What's the very last possible second that this task can start without impacting the final project due date? And then finally, by determining the differences between the early start and the late start, or the early finish and the late finish, we're able to calculate the slack. Any tasks that have slack are not on the critical path and therefore will be managed appropriately. Any tasks with 0 slack are critical path tasks. So let's put this into action. Step number 1 is to draw the network diagram itself. I'm going to keep my network diagram fairly simple, so we're going to have the start. And from the start, I have 2 separate tasks that have no predecessors. I have task number A, and I have task number B. Off of task number A, I have a successor task that I'm going to call task number C. B also is a predecessor to task number C. So we're starting to see our network diagram with the dependencies starting to flesh out. Task number C has a dependency on task number D. And task number D is the end of our project. So we have a very simple network diagram. Obviously, a real network diagram for a significant size project would be much larger than this. But again, in review, we have 2 tasks that are independent that begin our project, A and B. They can both start simultaneously to the beginning of the project. We have task C, which is dependent on both A and B being completed before C can start. And then once C has finished, we have task D, which can start as soon as C is finished, and then of course when D is done, our project is done. The next step in our network diagram is to add the effort. So we need to determine, as part of the project management process, how much work, what is the effort, how much time are the resources that are going to work on each of our tasks, A, B, C, and D, going to be required to get the job done. So let's assume task A has an effort of 5 days. It's going to take us 5 days to get task A completed. Let's assume task B has an effort of 7 days. It's going to take 7 days of work to get the project done, or to get task B done. Task C has an estimate of 4 days to get the job done. It's going to take 4 days worth of work to complete C. And finally, D has an estimate of 3 days to get the job done. Now, again, for simplicity in this network diagram, I'm assuming I have a single resource working full-time days at 100% availability, and saying that resource number 1 is going to work on task A, dedicated, uninterrupted, and is going to get it done with 5 days worth of effort, i.e. 5 days worth of duration. The same for B. The resource that's going to work on B, which is an independent resource from A, because I'm saying they can happen in parallel, is going to take 7 days of dedicated focus effort to get the job done. C is going to take 4 days of dedicated focus effort. At this point, it doesn't matter which resource is going to work on it. It can be resource number 1 because they're available from A. It could be resource number 2 because they're available from B. Or it could be yet a different resource based on the skill requirements for the project. But again, based on 100% availability, 100% utilization, it will take 4 days worth of effort, 4 days on the project to complete C, and the same applies to D, which is 3. Now, having been through the majority of this nugget series, I know you will appreciate that some of those conditions I have stated for drawing this simplistic network diagram to demonstrate the principles of network diagramming are not realistic. No one is ever available 100% of their time to work on projects. We need to make allowances for sick, for vacation, for unavailability. That is true. That again is why we will use a piece of software, such as Microsoft Project, to draw our network diagrams for us, because it will address the issues, the limitations, the impact of having resource number 1 required to put 5 days worth of effort in, but they're only available 80% of the time to make allowances for sick, vacation, and other unavailable. Ignoring that again, total effort, 100% availability, 100% dedication, 5 days, 7 days, 4 days, and 3 days to get the project completed. And again, this is assuming resource availability, that we don't have resource conflicts across A and B. We're defining the principles of how to create a network diagram. The next step is the forward pass. Based on the dependencies we have defined on our diagram, and based on the effort required to complete each task, we're in a position to complete our forward pass to determine what the early start and early finish dates are for each one of our tasks in our project. Before we go there, let's put together a bit of a legend for how this network diagram is going to flesh out. In this top left corner, we're going to enter the early start date for each of the tasks. In this upper right hand corner, we're going to enter the early finish date. In the bottom left hand corner, in step number 4, we're going to define the late start. And in this bottom right hand corner, obviously we're going to create the late finish. So with that in mind, we're going to go through and calculate our forward pass. The earliest possible start date for A and B, because they're at the beginning of our project, are 0 and 0. The earliest possible finish date for A, because A is going to take 5 days worth of effort, is going to be on day 5 of our project. The earliest possible finish date for task B is going to be 7, because 7 is the number of days it's going to take to complete B. Now when we move on to C, we have to make a decision. We have an analysis point as the part of creating our network diagram. Is the early possible start date for C 5? Or is the early possible start date for C 7? And the answer is going to be 7. C can't start until B finishes, so the earliest possible start date for C is going to be 7. Doesn't matter that A is done in 5. This is where slack is going to come into play. We'll do that in step number 5. We can't start C until B is done, which says the early possible start date for C is going to be 7, and the early finish date for C is going to be 11, which is 7 plus the 4 days required to complete C. Because the only dependency on D is C, its early possible start date is going to be 11, and the early finish date for D is going to be 14. So now this tells us that our project is going to be done on day 14. Day 14 is our completion date. That's what the forward pass is going to do. It's going to identify what the earliest possible completion date for our project is going to be, which is the network diagram based on the early start and the early finish dates for each of our tasks, taking into account dependencies between tasks. Our next step in our network diagram, step 4, is the backward pass. It's basically a repetition of what we did in step 3, but we're going to work in the opposite direction from the end of the project back towards the start, and we're going to calculate what the latest possible start date and the latest possible finish date for our project is going to be, allowing us to preserve the completion date of 14. So with that in mind, the latest possible finish date for D3 is going to be the same as the early finish date for D3 because that is the end of our project. The latest possible start date for D3 that's still going to allow us to complete on 14 is going to be 11, which is the 14 minus the 3, which is the number of days required to complete our task. When we move that backwards to C, again, when D needs to start, the only dependencies between D and C is the single dependency. That tells us that the latest possible finish date for C is going to be 11. If it doesn't finish by 11, then D is not going to start, and therefore it's not going to finish, and we're not going to meet our day 14 completion date. Same applies. The latest possible start date for C is going to be day 7, which again is 11 minus 4. Now, as we work backwards, in order for C to start on 7, A must be finished on 7, not 5. In order for C to be able to start on 7, A must be finished by 7 because that's our dependency. And if we take 7 minus 5, that's going to say the latest possible start date for A is going to be 2. That's telling us that A does not need to start on day 0 of our project. A could be delayed as late as day 2, and it's not going to impact our completion date for our project. If we take that down to B, again, in order to preserve a late start date for C of 7, B must complete on 7. So the latest possible finish date for B is going to be 7, and because B is 7 days worth of effort, the latest possible start date for B is going to be 0. So that completes our backward pass for our network diagram. The final step in creating our network diagram is to calculate the slack. Slack is calculated as the difference between the late finish and the early finish, or the late start and the early start. The number will be the same. It doesn't matter whether you do it from the late finish to the early finish or the late start to the early start. So in this case, there is 0 slack for task D because all of the numbers are the same. If we look at task C, the same is going to apply. Late finish minus early finish is 0, or late start minus early finish, or early start, again, is going to be 0. If we come down to B, the same is going to apply. 7700, our slack is going to be 0. But if we look at A, the difference from 7 to 5 is 2. Or the difference from 2 to 0, again, is 2. So this is telling us that task A, as I mentioned earlier in this diagramming process, has a slack of 2. A can start as late as 2 days into the project, and it's not going to impact the project's completion date. That's what the definition of slack is. The opposite to the definition of slack is critical path. And critical path is any task where the slack equals 0. So this tells us B to C to D is our critical path. Any impact of any time on the completion of B, C, or D is going to have an absolute impact on our ability to complete our project on day 14, and any impact that's going to be greater than 2, delaying task A from finishing, is also going to have an impact on our completion date, but we know we have that slack, we have that available time of 2 days, allowing A to start late or finish late. That's still not going to impact our ability to complete our project on time. That's the 5 steps associated with drawing network diagrams by hand. Step 1, you draw the tasks and identify the dependencies. Step 2, you add the effort required to complete each task. Step 3, you complete the forward pass, where you calculate the early start and the early finish for each task on your network diagram. Step 4, you calculate your backwards pass, working from the end of the project back towards the front. You determine what the last possible day the task can finish on to allow you to still meet your project completion date, and therefore you're able to calculate the late start date. You work backwards, and you do your backwards pass all the way back to the start of the project across all networks, all dependency chains in your diagram. And then finally, step 5, you calculate the slack, which is the late finish minus the early finish, or the late start minus the early start. One is as good as the other, and you determine where the slack is on your project. In the very simplistic diagram I just drew, which is represented here, I only talked about a single term called slack. In reality, there are 2 different terms for slack. There is free slack, which is task slack, and there is total slack, which is project slack. The difference between a task slack and a free slack and total slack is not evident, does not exist in a very simplistic diagram such as we just went through. The only slack was here, in which case the task slack for task A was 2, and the total slack for the entire project was 2. But if you consider a much more complex diagram where there are many more paths through the diagram, and let's just arbitrarily say that our critical path is this route right here. So the diagrams that I have encircled are my critical path. So A, B, C, D, E, and F, for example, are the critical path. They all have 0 slack. It doesn't take a lot of stretch of imagination, and I'm not going to go through the math, to see that this task could have a slack of 2, and this task could have a slack of 3, and this task could have a slack of 4, and this task could have a slack of 2, and so on, as you're working through the various dependencies as you calculate the backward pass for this complex diagram. So each of the individual tasks are going to have free slack, or task slack. The total project slack is the latest possible start date that any component to the project can start that is still going to preserve the final finish date for the project. So free slack is task focused, total slack is project focused. On a simplistic diagram, such as we walked through, they're going to be equivalent. On a much more complex diagram, it's easy to see how individual tasks, because they're part of different chains, are going to have different amounts of free slack, task slack, and how the net is going to result in a total project slack, which is the latest possible date that any component to the project can start without impacting our ability to finish the project on time. I've been using the term slack throughout the discussions in this nugget. It is an appropriate term. It is a commonly used term. Another term often used instead of slack is float. The terms slack and float can be deemed to be synonymous with each other. So free slack or free float is the amount of time that an individual task can be delayed without impacting the start date for the next task. Total slack or total float is the total amount of time that a task can be delayed without impacting the finish date to the project. In this nugget, we've looked at the process for creating network diagrams. We understand as project managers the importance of network diagrams. It defines our project schedule. It allows us to identify the critical path, which gives us the support that we need to fast track and crash our project to achieve project success. This nugget focused on the manual creation of network diagrams. Something we won't often do in a live project delivery situation, but it's important that you understand this manual process because I think it provides significant insight into the network process itself, gives you more of a feeling for how the project schedule, how the critical path has been determined, and is absolutely that you understand this manual process to answer some of the questions related to network diagram management on the PMP exam itself. There were 5 steps. You draw, you put in the effort, you do a forward pass, you do a backward pass, and you calculate the slack or the float, depending on which term you want to use. In the process of doing the forward pass, we introduced 2 new terms: the early start and the early finish. What's the earliest possible time a task can start? What's the earliest possible finish date a task can start? We talked about late finish. What's the last possible date a task must finish before it's going to impact the project completion date? And what's the latest possible start date that a task can start on, again without impacting the project's finish date? We talked about free, slack, float, and we talked about total, slack, float. Where free slack is the maximum amount of time that an individual task can be delayed without impacting the start date for the next task in the schedule. Total slack, total float, is the total amount of time that an individual task can be delayed without impacting the overall finish date for the project. Having all of this information is equivalent to what you're going to get from your project scheduling tool as it defines the project schedule. The tasks with no slack, no float, are the critical path tasks, which then is the information that we're going to focus on for fast tracking and crashing the project. This concludes our nugget on creating network diagrams. I hope this video has been informative for you, and thank you very much for viewing.